So let's start with a quick question. Please look at this scenario. In this scenario, we have two objects from the same height. If I let go of them, which will damage the surface more? That's the question. Which will damage the surface more between these two objects? Now, in scenario 2, sorry, not scenario 2, in case 2, we have the same object, but the first object is let go from this height, while the second object, it is thrown from this height. That is, it has certain velocity. It already has some velocity, but the mass is same. Now the question is, which will damage the surface more? Okay, I hope you guys have your answer. Next, we have three objects over here on the screen. A ball bearing, a marble, and billets ball, right? So they are let go from the same point. I'll show that. So all the three are let go from the same height actually. So the question is, which will have more destructive force, which will damage the structure more? Right? Was that obvious? So whatever you think is obvious, right? And whatever made sense over here, that the 10 grams object will have more, will damage the surface more. And in this case, the moving object will damage the surface more. This aspect of, mass and velocity and all of that speed and all of this, we combine it to be called as the linear momentum. The basic idea of linear momentum is that there is a difference in how much oops or IO each object has when it moves right. That's what physicians call linear momentum. Sorry, I read this wrong. There's a difference in how much oops or IO each object when it moves right. So whenever you have different objects moving, the amount of force with which they hit you, creating oops or IO scenario, that is dependent on how the object is moving. This physicians call it as linear momentum. This aspect of oops and IO is your linear momentum. It's like the combination of how fast something is going and how much stuff it's made up of. That's your linear momentum. So I hope you guys are able to tell what is the SI unit, what is the dimension, and what is the mathematics. So actually I gave the mathematics. So as a definition, it's a quantity of the motion possessed by the object. It is a quantity of motion possessed by the object. That's the definition. Mathematically, it will make more sense. Linear momentum is mass and velocity. Mass into velocity. So in this case, which will have more linear momentum by the time they reach the ground? Right, 10 grams will have more momentum. What about these two objects which will have more momentum by the time they reach the ground? Yes, 1 kg which is already moving will have more momentum, because by the time they reach the ground, it will have more velocity. Here the mass is same, the velocity is more. Here the velocity will be same. You'll understand that in gravitational chapter, that when two objects are dropped from the same height near the surface of the earth, they will gain the same amount of velocity. Right? There are a lot of conditions and all of that. Anyways, you guys will learn, but point here is mass and velocity plays a role in how much force or how much damage it will do to the object in front of it, or to itself as well. And that is your linear momentum. And so we have the mass into velocity as the formula. And when it comes to this, we have the ball bearing, which has a smaller mass compared to the marble and compared to billiards ball. Right? Billiards ball has the highest mass. All of them in some degree will gain the same velocity. It's not true, but point is, we'll consider that it will gain the same velocity. There are a lot of factors on the board and their surface and all of that, but approximately they'll gain the same velocity. So all of them have the same velocity, but their mass is different. So their destruction power is different. Okay, so that's what we are trying to discuss over here. And that quantity is called as linear momentum. It's represented by small p. Do you think it's a scalar or a vector quantity? So momentum is represented by P. Okay, yes. And it is a, let me actually write it off in this manner. Momentum is represented by small p. Then it is a vector quantity. So it is also equal to, not also, is equal to m into p, vector representation. Then what else? Dimension will be, dimension of mass is m, your dimension of velocity is L1, m1, t minus 1. So that will be your dimension. Then what else? SI unit, okay. SI unit would be kg meter per second. That's your SI unit. Then what else? SI unit, okay, done. So what did we learn? We got introduced to a new topic called as linear momentum. It's the OOP factor or the IO factor that we are looking at. So the main thing that affects this IO factor and the OOPS factor is your mass and velocity. So the mass, if it increases for the same velocity, it will have more damage. For the same mass, if the velocity increases, the one with the more velocity will have more damage, right? So this linear momentum is defined so. Mathematically, it is so. It's represented by small p. It's a vector quantity. SI unit is kg meter per second. Dimension is over here. Okay. You can pause and have a look and copy what makes sense to you guys. Again, make running notes.